this video is going to go over two-dimensional motion, and we're going to concentrate mainly on projectile motion. We'll talk about launching projectiles at a zero launch angle and angles other than that. So imagine if you're traveling at a constant velocity like this turtle. That means not only is your speed the same and you're traveling the same distance every instant in time, but you're traveling in the same direction. So this turtle is traveling upward at an angle, at a certain speed, at an angle or a heading of 25 degrees. That means that his velocity vector has a horizontal component and a vertical component. And if you remember from our discussions before, that velocity in the x direction is the velocity times the cosine of the angle, and the velocity in the y direction is going to be the velocity times the sine of the angle. And those are just the formulas for components. Since it's traveling at a constant speed, then every instant it not only moves along the velocity VO vector the same distance, but it also moves a certain distance in the x direction every instant and a certain distance in the y direction every instant. There's no acceleration going on in either scenario. But when we throw something up at an angle, it's very different. So imagine a ball that's thrown up at 100 meters per second at an angle of 30 degrees. So that means it has a forward motion of 87 meters per second and an upward motion of 50 meters per second using our components equations. Look at our vector diagram of this. As the ball initially is released, it has that 87 degree, at the 87 going forward and the 50 going upward. Notice that as it goes upward, the 50 gets smaller and smaller, so that at the very top of its trajectory, it has zero velocity in the y direction. What we're going to assume here is that the only force acting on this is the weight of the ball. And weight is a downward force and only acts in the down direction. So it will only act on velocities that are moving upward or downward. The velocity in the horizontal direction is never going to change because we don't have any other force. We are ignoring the effect of air resistance on this object. No other force is acting on it. So that 87 meters per second will always be 87 meters per second. That means that as it moves forward, it always goes 87 meters every second forward. But its velocity in the y direction is very different. It's changing, and it's behaving like an object that was thrown up at 50 meters per second. So in the horizontal direction, Vx is always going to be constant because there's no force acting on that direction. And that means that the acceleration in that direction is zero. We're going to assume there's no air drag at all affecting this projectile, and that's why this is true. In the vertical direction, Vy is accelerating, and Ay will be that of gravity, negative 9.8 meters per second squared, because the force that causes this acceleration is weight. So the basic assumptions are: ignore air resistance, gravity is always downward, and ignore the Earth's rotation, because if somebody throws you a ball, you and that person are both rotating, and so is the ball. It's rotating too. So the rotation of the Earth is the same for everybody. It doesn't make a difference. If the y-axis is upward, and that's the coordinate system we're using, then the acceleration in the x direction is zero, and the acceleration in the y direction is always negative 9.8 meters per second squared. So once again, let me just remind you that that negative 9.8 meters per second squared is independent of the direction of the velocity. In other words, whether you drop a ball or whether you throw a ball up at an angle, it doesn't matter. The only direction that's accelerating is the y direction, and it's accelerating at negative 9.8 meters per second squared. So if we look at the basic equations, we have a set of equations for the horizontal direction, and we have a set of equations for the vertical direction. The horizontal direction, our blue direction, there is no acceleration. So all our kinematics equations simplify down to one equation. Delta x equals Vx times time, or range equals Vx times time. Range is the distance away from the horizontal distance away from where it's launched. In the vertical direction, though, there is an acceleration of negative 9.8 meters per second squared. So if we take all our motion equations, we can rewrite them, the same motion equations that we've learned in the past. But instead of using an x, we use a y. Instead of using an a, we use a g. And we remember that the velocities vi and vf refer to that vy component, not to the velocity that you're throwing it at. So we get the same motion equations that we had before. They look a little bit different, but they're exactly the same.